So good day, sir. I'm Melissa Patino from BSA 3E. So today I discuss about 22.17 display po. So display of alphabets as well as numericals in response to electrical inputs, and the primary aim of alphanumeric displays. Arrays of LED or leads as well as CRT or Kajut raised tube displays are widely used for it. So I read-only memories or ROM that are used to facilitate generation of alphanumeric characteristics, and long series shift register for memory are now available in MOS or MOS and LSI form. So segments displays. A very common requirements in modern electronic in that of displaying alphanumeric characters, digital watches, pocket calculator, and digital instrument, all example of device that use such displays. So the base known display of this type in the so-called seven-segment display. So uh, it it comprises seven independently accessible photoelectrical segments, leads, LCD, gas discharge, fluorescent, or filament types of segments arranging in these pictures. So the segments are conventionally noted from A to G, and it is possible to make them display any numeral from 0 to 9 or any alphabetic character from A to F. So in a mixture of upper and lowercase letters by activating the segments in different combinations. The wiring patterns of LAT or lead 7 segments display is simplified by having one terminal as common for all 7 segments. So the common anode and common cathode internal connection for lead. So the common cathode leads have to be driven by active high de- decoder ICS, and the common anode leads have to be driven by active low decoders. So such connected to the 7 segments. So it may be noted that series resistors are included for each of the leads correspondence of the 7 segments. Further, an additional lead correspondence to the decimal points is also provided in the display, which again has a current limiting series resistor. So the typically value of the series resistors is 150 ohms for a segment current of about 20 mA. So lead 7 segments display driven. So to illustrate the operation of the circuits, let us assume that the ABC inputs is D is equals 0, C is equals 1, B is equals 1, A is equals 0, which is BC D 4, 6 with these inputs, the decoder or driving inputs A, F, G, C, D, and E will be driven low, connected to the ground, allowing currents to flow through the lead segments A, F, G, C, D, and A, thereby displaying the digit 6. So the B output will be high open, so the lead segments B cannot conduct. So leads are usually zero and off by transistor circuits. A widely variety of digital IC are available for providing suitable decoded driven signals for 7 segments display. So for display of alphanumeric characters, both numerical and as well as alphabets, 14 segments display units. So the 16 segments alphanumeric display system, which is used to generate additional characters such as those required in typewriter style keyboard. So yun po. That's matrix displays. So excellent alphanumeric characters can be displayed by making use of that matrix leads with a lead at each at that locations. So A 3 by 5 that matrix is used for display of numerical characters. That matrix making use for 27 dots. So this system displays the numerical characters is as illustrated in a figure. That matrix showing formation of characters. So the dots may be square or around with 0.4 mm side or diameter. So leads and LCDs are used for displays aluminum of dots. Uh, that matrix digital display with drill mononated dots is most popularly used in leads arrays and CRT. The 5 times 7 dots matrix format enable a far larger set of typically 192 characters to be obtained, including all the numericals, upper and lowercase letters, together Greek letter and other symbols. So 7 by 9 dots matrix format provide a letter representation of lowercase letter. So the 3 digits alpha numeric display system using 5 by 7 characters. So the function diagram of a digest alphanumeric display system making use of horizontal starbing is illustrated in this picture. So the alphanumeric are represented by a code this specified word length generated by the keyboard. The ASCII2 code is one of the most widely used format, including 26 English alphabets, 10 numerals, and 7 other symbols, and several other symbols. So wiring pattern for 5 by 7 leads characters. So the six bits as ASCII2 code for the keyboard is sequentially entered and stored in their inputs storage buffer. The codes in the inputs buffer refers to the three individual characters to be displayed. The array selector selects in the buffer, and the 6 bits output of the decoder is entered in a parallel into the selected buffer. The output of first input storage buffer is enabled by a time pulse in order that the 6 bit codes from it controls the characters in output from the read-only memories or ROM. If all the 5 columns of the leads arrays illustrate in speaker and driven now, the appropriate characters can be displayed in the dynamic displays. However, only one column is energized or driven at a time, and the 5 columns are driven sequentially. When the first 5 columns have been driven, a timing pulse change in the code input to ROM to correspond to that starts in buffer 2. Similarly, when the columns 11 to 15 are being driven, the data to the ROM or ROM is from input buffer 3. After all the columns have been driven, the sequence repeats. If the repetition rate exceeds about 20 per second, a flicker-free array of alphanumeric characters is obtained. So bar graph display. So basically, the bar graph display is basically an arrays of leads or LCD or gas discharge panels arranged in an N by M matrix form, by which the signal's magnitude in indicate a linear or rectangular format. So the leads bar graph consists of a number of leads arrays, row and wise, arranged in a single or multiple columns. The packet this density sign can be as large as 50 mm times 100 mm. So the main advantage, such displays are generally employed in the panel meters to accept analog input signals and given an equivalent display of the input signals level by illuminating the corresponding leads.